So the first problem that we have over there is about mole to grams. Okay, it's about mole to grams, and it says, what is the mass in grams of 3.5 moles of the element copper, Cu? Okay. So let's see. What do we need to do in the first place? We need to highlight the given, okay? We need to highlight the given, or we need just to identify where the given is. So what is the given in this problem?
The mass in grams.
No.
Me?
That's what the problem is asking you to find, but what is the given?
3.50 mole.
3.5. 3.5 and the unit. The units are moles, okay? So for this particular problem, you're going to identify the given as 3.5 moles of the element copper, okay? So the given in this problem is 3.5 moles of copper. Yes, guys, you should copy everything that I do, you should copy it, but I prefer that you pay attention. In Google Classroom, I send you the PDF file with all the whiteboard that I use, okay? So if you just want to pay attention, it's okay. If you don't want to write after the class is over, you can write the problems here and also pay attention. It is up to you. But yes, all these exercises must be in your notebook, okay? So the given in this problem are the 3.5 moles of copper. So we say, we start. .5 moles of copper, okay? Now, in the periodic table, what do we know about copper? What is the atomic mass?
63.55.
So, what do we need to do to turn this into a conversion factor? Copper is equal to 63.55 grams, okay? So, what do? We say that there are 63.55 grams of copper in 1 mole of copper. Please don't be lazy. Write all the units, okay? So you can write the molar mass like this, grams over mole, or moles per gram, okay? You can write it in the reciprocal form. In the reciprocal form, it will be 1 mole of copper, containing 63.55 grams of copper. So I have 2 factors, okay? I have 2 factors. What factor do I have to use to turn those moles into grams?
The first one, the A.
The A, okay, that is good. So we say, okay, we're gonna use A. In 1 mole of copper, you have 63.55 grams of copper. Get rid of moles with moles, copper with copper. How much is this? You can write your answers in the chat so if you want to participate. Remember, everything that is above, you multiply. You can place a 1 over there. Okay, 222.43 rounded. Okay, 0.43 rounded. That's the answer. Very good. 222.43 grams of copper. Now, when we need to convert from grams to moles, let's see this example. A chemist produced 11.9 grams of aluminum, Al. How many moles of aluminum were produced? So they're asking me to find moles, okay? So I need to look for moles. How many moles is going to be my unknown? And what the problem is giving me is the information about my grams of aluminum, okay? So this is going to be given. Wait, is that, I don't know why, but it's, the connection is very slow. Okay, there you go. You have your 11.9 grams of aluminum. That's going to be the given in the problem. So the conversion that you have to do is from grams to mole. Whenever you have to do this, whenever you see grams are involved, you need to use molar mass as a conversion factor. So this is a procedure that you can do it only in one step. Now, what is the molar mass that we have to use? From what element?
Aluminum.
Aluminum.
Okay, we know that aluminum is equal to how many grams?
26.981.
26.981, okay? So we say there are 26.981 grams of aluminum in 1 mole of aluminum, okay? Or we can write it in that reciprocal version of it, like in 1 mole of aluminum, you have 26.981 grams of aluminum. You can do it in one way or another, A or B. So we start with a given. The given are 11.9 grams of aluminum. I place it over my invisible one that now becomes visible. And then I see I have grams in the top, so I need to write grams in the bottom. So what conversion I have to use, A or B?
B.
B. 26.981 grams of aluminum. Kelly, your microphone is on. Okay, so the grams are in the bottom. So in the upper part, all I need to write is 1 mole of aluminum. I get rid of the units, grams with grams, aluminum with aluminum. How much is this?
0.44.
0.44 moles of aluminum. So you can see that anytime we have grams to moles or moles to grams, we're going to be doing just one step. It's a one-step process. Now, this time, grams to atoms, for example, this is a conversion that requires 2 steps. And we're going to make use of a conversion factor that is known as Avogadro's number. Okay, so pay attention to this example. Whenever you see that atoms or particles, I'm going to write these keywords, okay? Atoms, particles, What particles do you know? What subatomic particles do you know from the atom?
The protons,
Protons,
electrons.
neutrons,
Electrons.
electrons. Okay, so anytime you see atoms, particles like protons, neutrons, electrons, or molecules, for example, these words are going to tell you that you need to make use of a conversion factor that is known as Avogadro's number. Avogadro's number is a conversion factor, it's an equivalence, okay? So that equivalence is 1 mole of a substance is going to be equal to Avogadro's number, which is this number that you're gonna see, 6.022 times 10 to the 23rd power. Okay, 1 mole of whatever substance is going to have Avogadro's number, 6.022 times 10 to the 23rd power, number of, that could be atoms, particles, protons, neutrons, electrons, or molecules. It's like the concept of the dozen. If I say 1 dozen of cars, you know that there are gonna be 12 cars, okay? And it's going to change according to the object. In this case, it's going to depend on the substance that we are talking about, but also this is going to be a conversion factor, Avogadro's number. Avogadro's number is 6.022 times 10 to the 23rd power. And these are atoms, molecules, or any type of particles. Okay. Atoms, molecules, or particles of the same substance that we were talking about, of the substance, in this case, X. So if I talk about, like in this example, it's about the element copper. So it's going to be 1 mole of copper is going to be equal to 6.022 times 10 to the 23rd power atoms or molecules or particles of the element copper. Valeria?
Miss, I don't understand one thing. Why you put 6.022?
That is it's like a conversion factor, Valeria. Like, for example, when I wrote in the board that 1 kilometer is equal to 1,000 meters, that is a value that is known like a conversion factor. Well, in chemistry, we use Avogadro's number, which is this number over here. We use it as a conversion factor. It's a given, okay? It's a conversion factor, like that in 1 kilometer you have 1,000 meters, or like in 1 meter you have 100 centimeters, or like another conversion factor like the molar mass concept, that 1 mole has 26.981 grams of the same substance. Genesis.
All that you're writing is in the presentation, right?
Can you repeat? I couldn't hear.
What you're writing right now, what you're explaining, is in the presentation.
Yes, exactly. I'm gonna send you the whiteboard as a PDF file. Efraín?
So Avogadro's number will only be used when we are working with particles, right?
Exactly. You're gonna use Avogadro's number only when the word atoms, particles, protons, neutrons, electrons, or molecules are mentioned in the problem. Like in this sample problem that it says, what is the mass in grams of 1.2 times 10 to the 8th power atoms? So you say, this is about atoms, so I have to use Avogadro's number. Valeria.
Miss, I didn't even understand it.
It's okay. I'm going to do an example. Okay, I'm going to do an example. You're going to see how is this going to work. Well, these are two-step processes. I'm going to do one example before this one. That is going to be from atoms to moles. Okay. Okay. I'm going to do this example first, which is going to be one step as well. So we can go and see this exercise. Is that this one requires two steps. Okay. Now take a look. I'm going to write a problem. Okay. How many moles of copper are in 7.5 times 10 to the 24th power atoms of copper? Well, take a look to this example. Take a look to this example. I'm talking to you about atoms, okay? This number, 7.5 times 10 to the 24th power, atoms, the word atoms is gonna tell you that you have to use Avogadro's number, okay? Anytime you see atoms involved in a problem, notice that you have to use Avogadro's number as a conversion factor. So they are giving you atoms and you need to convert to moles because the problem is asking you how many moles of copper. So this is going to be your unknown. So we always start with the given. The given is in blue, okay? You're always gonna see me using those two colors, the given in blue and the unknown in red, okay? So we're going to start with the given, and remember, because we're gonna be using Avogadro's number, we're gonna be using the conversion factor, that in 1 mole of whatever element, you have 6.022 times 10 to the 23rd power. Because we're talking about atoms, it's going to be atoms in this problem. Atoms of the same element. We're talking about copper, so this will be about copper. If I change the element, don't worry, okay? Just change the name of the element, but the procedure is going to be the same. So this is the conversion factor that we're gonna use. And remember, what do we do with the conversion factors? We write them as fractions, okay? So we say that in 1 mole of copper, you have 6.022 times 10 to the 23rd power. In this case, atoms of copper. Or you can write it in the other way, like 6.022 times 10 to the 23rd power. Atoms of copper are inside 1 mole of copper. So this is the conversion factor, okay? And this is written, it's the same conversion factor, but written as a fraction, okay? So we start with the problem. We start with the given. The given are 7.5 times 10 to the 24th power atoms of copper, okay? And we're going to write it over the visible one. Wait a minute, because this is kind of slow. Okay, now it's good. So take a look. Atoms are written in the upper part of the fraction. So I need to use a conversion factor where my atoms are going to be in the bottom. So which one I'm going to use? A or B?
A.
A.
A. So we say 6.022 times 10 to the 23rd power atoms of copper are in 1 mole of copper. Don't be lazy, write all the unit. Okay. Now you get rid of atoms with atoms and copper with copper. Now, how do you do this in your calculator, which is the other part? In your calculator, let me bring a picture of a calculator so I can tell you what keys you have to press. Casio.
Miss, is I even understand how you get 6.022, but I don't understand.
Is that, Valeria, that is a conversion factor. It's like for example, like the concept of the dozen that I told you. To what number does a dozen represent? If I tell you a dozen of eggs, how many eggs I'm talking about? When I talk about a dozen or 1 dozen of whatever thing, if I say, for example, notebooks, I'm talking about exactly 12 notebooks because the word dozen represents the number 12. Okay. In the case of atoms, the word atoms, particles, or molecules, all those words represent Avogadro's number. Okay, for example, 1 dozen of notebooks are 12 notebooks, but 1 mole of a substance, let's call that substance aluminum, is going to have always 6.022 times 10 to the 23rd power. It's a given, okay? You have to memorize that number. You have to memorize that number. Just like you memorize that in 1 meter are 100 centimeters, you are going to memorize this number, 6.022 times 10 to the 23rd power. These are molecules or atoms or particles. So whenever you see the word atoms, it's going to represent this value, this number. Just like when you read the word dozen, it represents the number 12. When you read the word atoms, it's going to represent this number. Now, how do you use it in the calculator? Because this is a different story. One story is to do all the procedure here, and a different story is how to do it in the calculator. Let me, okay. In your calculator, this is what you're going to do. You're going to press 6.022. You're going to press 6.022, and the part that says times 10, you're going to press the key exp, or if you have the newer version of it, you're going to press the key times 10x, and then the power. The power is 23. That's how you do it in the calculator. So how are you going to do this? 7.5 exponential 24 exponential 24 times 1 divided by Avogadro's number, 6.022, the key exp 23. Did you get to do it?
I got 12.45.
12.45.
Yes.
Me too.
Do you get the same answer? Do it. Do it now in this moment because in
Yes,
this
Miss, I
way.
get the same.
Okay.
I got the same.
12.45. What units are these? The units that you didn't cancel that are
Moles.
moles of copper. Always write the units. So as you can see, the number is overwhelming because it's a weird number, okay? But in the end, it's just another conversion factor. You're gonna write it in the way that you have to cancel the number of atoms with number of atoms. Okay. Did you all get the same answer? Okay, I will ask you something different now. Did you get a different answer than 12.45? So remember, this process that I do here, I do it only for teaching purposes. You don't need to show me this procedure in your homeworks because I noticed that some homeworks that have that procedure over there, so that is not necessary. I do it like this only for you to see what key you have to press in your calculator, but you don't need to write it down. Or yes, write it down in your notebook, but when you do a homework, no need to write it down. Now, let's try one more by using Avogadro's number. Take a look to this question. This is another example. It says, how many atoms of aluminum are in 1.48 moles of aluminum? So, in this case, what is the given in this problem? What is the problem given?
1.48.
Okay, they are giving me 1.48, but in this case, moles of aluminum. And they're asking me to find how many atoms, okay? So I'm gonna be using, because the word atoms is included in the question, I'm also gonna be using Avogadro's number, okay? So I'm going to start with my given. Well, first with the conversion factor. In 1 mole of aluminum, how many atoms I'm going to have?
Six point 022 times 10 to a 23rd power.
Exactly. Times 10 to the 23rd power atoms of aluminum. This thing is not updating. Okay, now it is. Okay, so this is the conversion that you're gonna be using. We start with the given 1.48 moles of aluminum. I know these things, I don't know, my connection is very slow. I mean, it's not slow because I can upload my video very fast. But the whiteboard, I don't know what's wrong. Okay. Okay. So we start with a given, and I'm gonna place it 1.48 moles of aluminum over 1. Okay, over 1. So where do I have to write moles of aluminum? Up or down in the conversion factor?
Down.
Down.
1 mole of aluminum must be written down. And above, I have to write 6.022 times 10 to the 23rd power atoms of aluminum. I get rid of the unit mole aluminum with aluminum. Why this thing is not updating? Let me close the app. Maybe if I open it again, it's going to work. Okay, there it is. More or less. So it's not actually working. Well, so you write it in this way, so you can get rid of moles of aluminum with moles of aluminum. And in the calculator, you will do it. How much do you get in the calculator?
8.91.
Times 10 to the? In the calculator, it shows
Tony,
an
that
exponent.
was the answer.
There, next to the number, it has like an exponent in a
Times
smaller
10 to
number.
the 23rd power.
Times 10 to the 23rd power. And these are atoms of aluminum.